Malik, and I believe we are going to...
Dear colleagues, good afternoon.
Give me a second. As you can tell, we are going to listen to him via a pre-recorded...
It's a real pity that some of our recent results will be presented virtually, but for now, this is the only option left. Coming to the talk. Zoned clinopyroxenite-dunite massifs, also termed as Uralian, Alaskan, and Aldite type complexes, are well known because of the associated platinum placer deposits. Despite numerous studies, the origin of these massifs and of the associated platinum mineralization remains unresolved. To gain further insights into the origin of the platinum group element mineralization associated with these massifs, we have carried out a combined mineralogical, highly siderophile element abundance PT, rhenium, osmium, and copper and sulfur isotope study of chromitite, osmium, iridium alloys, ruthenium, osmium sulfides, iridium, rhodium sulfides, and PT iron minerals from chromitites and placer deposits of the Guli clinopyroxenite-dunite massif in polar Siberia, and the Nizhny Tagil and Svetlobor clinopyroxenite-dunite massif in the Middle Urals. We integrate an application of electron probe microanalysis, whole rock abundance, and high precision osmium Teams isotope analysis of chromitite and osmium-rich alloy samples, copper isotope analysis of PT iron minerals, and in situ sulfur isotope analysis of laurite and cushinite, using laser ablation at high spatial resolution. Guli, exposed part of the Guli massif, is mainly composed of an ultramafic complex, which represented by dunite, chromitite, verlite, and magnetite-bearing clinopyroxenite. Our study is based on the osmium-rich minerals sampled in an area of the middle flow of the Igor River and the Burlakovsky stream in the central part of the Guli massif. Also on chromitite that outcrops in headquarters of the Igor River sample G4 in the southern part of the massif, and PT iron alloys derived from the quaternary deposits of the Guli River in the western part of the Guli massif. The total PG concentrations in chromitite samples of the Guli massif show the enrichment of osmium, iridium, and ruthenium over platinum and palladium, a similar trend resulting in a negatively sloped mantle normalized PG pattern is characteristic of podiform chromitites from mantle sections of dunite Harzburgite massifs. The majority of nuggets at Guli, both single crystals and polyphase aggregates, are osmium-rich alloys, osmium according to classification of Harris and Cabri, with considerable variation of iridium from one nugget to another. The osmium-rich alloys in this study are characterized by rather primitive composition. We adopt in this study the formation age of 250 million years for the chromitite and associated PGM. The dendritic initial gamma osmium, gamma 187 osmium values for native osmium and chromitite are almost indistinguishable within uncertainty. Similarly, dendritic values of mu186 osmium values for chromitite and osmium-rich alloys are also handritic, albeit the later cluster at the upper end of the handritic range. So these indicate that the highly siderophile element budget of the chromitite and native osmium was largely controlled by that of the mantle domain that evolved with long-term near-handritic rhenium osmium and platinum osmium ratios. This source is within the range of those for the majority of komatiite and abyssal peridotite sources and handritic meteorites. The Nizhny Tagil and Svetly Bor zone massifs form part of the platinum-bearing belt of the Urals, which is located along the 60th meridian for more than 900 kilometers. Platinum iron minerals selected for this study were sampled from vein disseminated chromitite segregation confined to the marginal parts, areas of coarse-grained dunite in the central part of the Guli massif, and are restricted to Alexandrovsky log platinum deposit and Krutoy log platinum deposit. Also, other minerals derived from similar geological setting at Svetly Bor and placer deposits within the Guli complex. Let's have a look on the examples of vein disseminated chromitite studied at Nizhny Tagil. High temperature ferrone platinum that has composition close to PT2 iron, commonly replaced by intermediate members of the tetraferroplatinum tulaminite series. The presence of reaction rings composed of minerals of the tetraferroplatinum tulaminite series, which replace high temperature ferrone platinum, is indicative of their secondary origin. Most researchers associate the formation of this low temperature PGM assemblage with serpentinization of ultramafic rocks. So let's have a look how these minerals look in ternary diagrams. Isoferroplatinum at Svetly Bor and ferrone platinum at Nizhny Tagil, commonly replaced by intermediate members of the tetraferroplatinum tulaminite series. Here we show composition of primary PT iron alloys from the Svetly Bor massive, red circles, Guli massive, squares, blue squares, and Nizhny Tagil green diamonds. All the samples of primary PT iron minerals have delta 65 copper values averaging around 0. We know the similarity in copper isotopic composition for samples of isoferroplatinum from the Svetly Bor, blue circles, and samples of ferrone platinum from the Nizhny Tagil, black circles, and Guli, orange circles. Meanwhile, minerals of the tetraferroplatinum tulaminite solid solution series are characterized by lighter copper isotopic compositions. Let us quickly have a look on chemistry of ruthenium osmium sulfides in iridium rhodium sulfides and osmium iridium alloys from chromatites of the Svetly Bor circles and Nizhny Tagil diamonds from these massifs. So this is an example of PGM assemblage at Svetly Bor, which we can see inclusions of polyphase inclusion of Kreshimir and laurite, and monophase inclusions of osmium iridium alloys in PT iron minerals. The delta 34 sulfur values in laurite and rhodium-bearing cushinite, forming part of polymineralic assemblage with isoferroplatinum, show a relatively narrow range from minus 0.8 to 0.4 per mil. Laurite with ruthenium number 8591 have delta 34 S values of around 0, with a mean of minus 0.15 per mil and a standard deviation of 0.24 per mil, which are similar to rhodium-bearing cushinite with delta 34 S values ranging from minus 0.8 to 0.4 per mil, a mean value of 0.23 per mil and a standard deviation of 0.45 per mil. The sulfur isotope signatures of the studied PGM are similar to those of ruthenium osmium sulfides from the Guli massif, which cluster in two types, those with osmium iridium alloys and ruthenium osmium sulfide, namely laurite with PT iron alloys. And now let's come to conclusions. The dendritic initial gamma 187 osmium values for native osmium and chromitite and dendritic initial mu 186 osmium values for chromitite indicate that highly siderophile element budget of the chromitite and osmium alloys was largely controlled by that of the mantle domain that evolved with long-term near-dendritic rhenium osmium platinum osmium ratios. These sources within the range of those for the majority of comatite and abyssal peridotite sources and dendritic meteorites. Second, collectively, the studied samples of primary high-temperature ferrone platinum and isoferroplatinum have an overall delta 65 copper range that cluster around 0. Secondary low-temperature PGM, represented by the tetraferroplatinum toluminite solid solution series, have copper isotopic composition ranging from minus 1.15 to minus 0.72 per mil. In this context, the lighter copper isotopic composition of secondary PT iron minerals compared to that of primary platinum iron minerals is consistent with the secondary nature of isotopic variations due to evolved composition of the ore-forming fluid during the low temperature formation of the tetraferroplatinum toluminate series. Finally, the mantle source of the sulfur is consistent with the osmium isotope data obtained for ruthenium osmium sulfides, osmium-rich alloys from the Nizhny Tagil and Guli massifs, previous studies, and this study implying that highly siderophile element and sulfur were derived from the convecting upper mantle that evolved with dendritic osmium and sulfur isotopic compositions. This study was financed by the Russian Science Foundation and is gratefully acknowledged. Thank you for your attention and all the best for now.